much reflection and so on.
And it's now 1 o'clock, so we can begin.
Okay.
I think you see Vint Cerf there. I think you should see Vint full screen now. Vint,
hello there.
There we go. Vint Cerf doesn't need an introduction, but let me tell you a few things that not everybody knows about it. He has a PhD, which he got at UCLA. Who was your mentor at UCLA?
Well, I had two. My thesis advisor was Jerry Estrin, and on my committee also was Len Kleinrock, and Len was the man I worked for in the Network Measurement Center during the days of ARPANET's implementation.
And Len is going to be on your panel when you come to the symposium.
That's correct, in October, that's right.
The symposium is free to Internet Society members and government folks. I believe...
No, it's the Marconi Society.
It's the Marconi Society Symposium, but the Marconi Society graciously has allowed Internet Society folks free access, so there is no reason why everybody in Washington shouldn't be at the National Academy of Sciences on October 2nd, because a dozen of the best engineers in the world. They've also played a crucial role in the Internet Society and ICANN, and he seems to be in the middle of almost everything I see on the Internet. Last time I saw him in person, he was headed over to meet with the president of Estonia, who wanted to think more about the open Internet. All of that comes to Vint. Vint, when you do your panel on October 2nd, what are the issues you're going to bring up?
Well, I think we're going to do at least 2 or 3 things. First of all, I'm very interested to get from each of the panelists a kind of perspective on where they think the Internet is heading. The whole panel is looking towards 2025. And seeing the Internet's evolution from these multiple perspectives, I think, will help a lot. The other thing which is important is that each of them has brought different technological capabilities. Has brought the technological capabilities to the discussion. Len, for example, bringing a very strong theoretical and analytic component, and others, application, engineering and applications capability. So I'm expecting to look at trends, and I'm also expecting to see whether anybody can identify some unexpected sort of black swan events that might come along. What technological barriers might be shattered, for example, that would make a big difference for the Internet? And before we went formally open on this show, you and I were talking a little bit about very high frequency kinds of operations up in the 30 to 50 to 60 gigahertz range or more. And I think that technologies like that may open up opportunities that we never had before. So I think we'll certainly talk about the technology side and the trends there, but I think we'll also have to talk about other things that are impacting Internet's evolution, the economics of the Internet, the governance of the Internet and its use and its abuse, I think will also inescapably have to come up in part of that discussion. So it will be a very broad menu, I think, of topics that we'll try to engage in.
Who else is on the panel? I think you have Bob Kahn.
Bob Kahn is on the panel, the co-inventor of the TCP/IP protocols and the Internet architecture, and in fact the guy that started the program. And I'm drawing a blank right now.
We've got Paul Rogers there.
Yes, Paul Rogers. Paul Rogers, of course, yes, he's done some absolutely amazing work on radio transmission, and in fact, he will be the honoree for this year. So. For the Marconi honoree. So this is going to be a very exciting panel, I think.
The Marconi Society every year gives a $100,000 prize. It's often called the Nobel Communications. You've won an enormous number of awards. Have you ever been up for a Nobel?
I think that Nobel prizes are not available to people whose career fields are in mathematics or branches of mathematics, and networking tends to be considered a branch of mathematics from the Nobel point of view. the closest any of us could possibly come, I think, would be the Peace Prize. And in fact, the Internet was nominated twice for the Peace Prize in the last couple of years. But you can imagine that's a very political kind of selection. So my guess is probably not.
So the alternative, if you happen to be in this field, is the Marconi Award. And that's this higher award you get. Polarizes companies earning it this year and years before. And we have, I believe, 7 Marconi winners in the symposium. People like John Chaffee, who's called the father of BSL, and so on. Now, what are the issues for the future that you think?
I'm sorry, you just faded out, Dave.
Sorry. What are the issues critical for the future of the net that you're thinking of?
Well, let's take this from, first of all, from the policy point of view. Right now, there's a great deal of discussion and debate over how the Internet and its applications and use should be managed from the policy point of view. There are some countries that would frankly like to suppress the freedom of speech and freedom of access to information that people have, at least have had historically with the Internet, and so there's tension there. It's also clear that there is abuse of the network, people who send malware out, people who do denial of service attacks and manage to corrupt and possibly coerce peripheral devices, computers and mobiles and so on into botnets and then abuse the computer power that they obtain that way. So there are a whole series of issues arising there. People are looking not only for freedom of speech, but I think they're looking for freedom from harm. And this is not strictly and purely a technological problem. Part of it is clearly the use of strong authentication, the use of cryptography and other kinds of mechanisms for protecting the confidentiality of content or its integrity is one side of the equation. But the other side of the equation has to do with people being thoughtful about how they use the network and not clicking on things that have extensions like PHP and EXE unless they know what they're doing, not clicking on random emails that might be attempting to get you to go to a place that you don't want to go, like a website pretending to be your banking service provider. So I think we have, each of us, individuals, have a responsibility to learn how to use the net in a safe way. But we also look to the operators of the network and the designers and engineers and standards makers to pay a lot of attention to protecting us with better quality software and hardware. And then finally, I think we need to have international agreements that will allow law enforcement to deal with the fact that victims might be attacked by people in other jurisdictions, even other countries. And in order to combat that problem, you need to have international cooperation. So all of that, I think, is a pretty comprehensive and pretty complex problem to solve. And in a way, it's a good thing to have this problem because it means that the network has spread pretty dramatically around the world. And if you don't mind my going on to one more point, and that's getting access to the Internet for everyone. It's a non-trivial exercise. Investments have to be made in infrastructure to make that happen. We are seeing very rapid penetration with mobiles and smartphones in particular, but they all have to come to ground eventually. The radio ultimately has to get attached to an optical fiber network or some high-speed access point, and so we have to pay attention not only to the wireless part, but the wired part, and certainly the Internet exchange points that link the various networks together. So there's plenty of infrastructure work to be done here on top of everything else.
The question that I wanted to take you to. By 2025, the majority of people on the Internet will probably be on mobile, will probably be from Asia and from Africa. The number from Cisco is that there'll be more Internet users in Africa around 2017 than in the United States. What difference will that make?
Well, I think it's already making a difference. The current state of affairs is that perhaps on the order of 350 million people are online in North America, but there are 2.7 to 3 billion people online around the world. So, I mean, we're already very clear that that the origins of the network and whatever, let's say, political inclinations have driven its design, architecture, and deployment, stemming from the U.S. and from Western Europe, is clearly already ending up in a much broader environment, much broader political and ethnic and social environment and economic environment than it was during its early stages of development. So we're already influenced, I think, by the applications that are appropriate, the local information that people are looking for, the economic environment in which they find themselves looking for utility out of the internet. So certainly our colleagues and friends in Africa and in Asia are already coloring demands on the network with, for example, the need for non-Latin character sets to support World Wide Web applications has been dealt with using Unicode in the World Wide Web, and that same principle, the use of Unicode, is also showing up now in the domain name system, where it's possible to have domain names that are written in scripts other than Latin characters. So I'm convinced that the environment in which the internet will flourish as the 2025 approaches will be very much a consequence of the changed way in which people find it, the network useful to use.
So, which is really close to my heart on this. David Cohn of Comcast offers a $10 internet connection, which is now 5 megabits, any poor family in the United States. He talked about maybe extending that, possibly to Medicaid recipients, possibly to senior citizens. There aren't that many senior citizens on the internet. Comment?
Well, actually, thank you for bringing that up. It reminds me of being on stage with Rob Reiner and Whoopi Goldberg in front of an AARP audience in Florida in one of their annual meetings. And I had a slide that said, basically, you may think that, the old timers don't know how to use the internet, but I have news for you, we invented it. So my first reaction right now is that more and more people are, in fact, getting onto the network and making use of it in ways that we might not have predicted. And second, I think there's a great deal more attention being paid to simplicity of use, the applications that don't require complex user interactions in order to make use of them. And so my guess is that we will see an increasing number of older people online. In fact, if I remember correctly, at least the statistic that I recall from Facebook a year ago, thereabouts, was that the most rapidly growing component of their user population was over 45 as opposed to under 45. So this suggests to me that the internet may not yet be for everyone, but it's on its way. Are you still there?
Question came across. I couldn't see it all on the full screen. It was talking about accessibility to 13%. And I think the rest of it was for people with disabilities. My hearing is not what it used to be. Tell me what's important there.
So this is actually a really important topic for me personally. As some of you know, I'm hearing impaired, so I'm very conscious of the importance of translating sound into something visible. For example, captions on television or video. I think that there is a huge opportunity there to make the network more useful for everyone. In some cases, what we find is that some disabilities come along just at any time, and some of them happen with age, and the consequence of that is that the, let me call them impairments or impediments to using online systems, in fact covers quite a broad range of people and age groups. So this turns out to be pretty important because if we think about accessibility only in terms of people with some specific kind of disability, you miss the possibility that whatever actions and design choices you make to make it more accessible might actually benefit a much broader population. So personally, my motivation is to find ways of making the network accessible to everyone, regardless of whatever impediments there may be. The other thing that's important is to recognize that these various impediments are not uniform. And that, for example, visual impairment ranges everywhere from perhaps a problem with focusing, like nearsightedness or farsightedness, all the way up to and including complete blindness. And the same kind of thing is true for people's motor abilities and people's ability, audio capability, oral capability. So this is a huge area that's ripe for improvement, but it also has lots of economic incentive behind it.
By the Marconi Society with Marconi Fellow Vint Cerf. Vint, along with 4 other distinguished engineers, are going to be in a panel in Washington, D.C. on October 2nd. We hope you all come to the National Academy of Sciences. The sessions include 8 of the Marconi Fellows, the leading engineers in communication. They're free if you work for the government or for members of the Internet Society. Go to marconisociety.org for more details. That's marconisociety.org. The honoree this year is Paul Rush, who invented Nemo. Remarkable stuff. He came up with it in '93, and it's now getting into almost every smartphone and every Wi-Fi in the world. He sent a question. Open has different meanings. One aspect of openness is being open for innovation and for technology. Applications are easier. That has supporting factors, structuring standards and protocols for flexibility, mechanisms for testing and scaling up new ideas, and a robust research infrastructure. But there's a tendency of large internet companies to block innovation that threaten product lines. Can you tell us some stories about the phone companies and the internet in the early days?
So, well, first of all, the predecessor to the internet was the ARPANET project, sponsored by the Defense Advanced Research Project Agency. And in those days, this is back in the mid to late 1960s, the Defense Department, that basically, or DARPA in particular, wanted to build a network so that the computer science community that they were supporting to do research in computer science and artificial intelligence could share computing and software resources with each other. And this sharing arrangement would allow all of them to advance much more rapidly in their research. And in fact, AT&T, which at that time was the primary carrier, not counting a lot of the small rural carriers, was approached and asked whether they were interested in participating in this packet switching idea, and they basically rejected that as not being a very functional. They didn't think it would work, but they were happy to sell leased circuits to ARPA to build its backbone network. There was another element of this, which is not just the telcos, but also the computer companies themselves. In that time frame, were in fact already exploring and implementing networking capability, but what they tended to build proprietary systems that only allowed their brand of computer to talk to each other. So Digital had DECnet, and IBM had something called Systems Network Architecture, or SMA. Digital had, or HP had something called DS, which I think stood for Distributed Systems, but I'm not certain of that. But these proprietary systems didn't allow computers of different brands to interconnect. So the ARPANET demonstrated the possibility of allowing computers of different types to interact with each other using a standard set of protocols over this packet-switched ARPANET. When Bob Kahn and I began working on the internet idea, we extended that to say that an arbitrarily large number of packet-switch nets, regardless of their medium, whether it's radio or satellite or optical fiber or dedicated phone circuits, could in fact be made to ever work on an end-to-end basis. So it was blending together different underlying transport technologies with the notion of heterogeneous computers all interacting with standard protocols. There was a lot of resistance in the commercial world to this idea. And then as the idea began to get a certain amount of momentum, there was a great deal of interest in a competing design for internetworking called Open Systems Interconnection, or OSI, which was being pursued by the International Standards Organization. Now, ironically, the Internet project, which officially began in late 72 or early 73, had standardized its version of protocol, the TCP/IP version 4, which is mostly what people are using today, by 1978, and then proceeded for the next 5 years to implement it on as many different operating systems as possible. And it was turned on in January 1st, 1983. Well, in 1978 is when the ISO program began. So Open Systems Interconnection papers and documents and protocol designs were developed over that period of time. And just as the Internet was being turned on, the Open Systems Interconnection protocol reached a sort of a state where there was quite a pile of documentation for these protocols. And because it was supported by an international standards organization, a lot of countries, including America, decided that that must be the right thing to do because we would want this to be an international standard. So there ensued after that a period of at least more than a decade where there was real competition between the OSI design and the TCP/IP Internet design. Ultimately, the TCP/IP designs succeeded, partly because they had been implemented earlier and there was more experience with them, and also they were being implemented and incorporated in various operating systems. So Digital and IBM and Hewlett-Packard's research labs implemented the Internet protocol well ahead of any implementation of OSI, and those were then available ultimately when it became attractive to make them available commercially somewhere around the late 1980s, around 88 or 89. So there was a lot of Sturm and Drang. It's not like this was a smooth sailing, simple hockey stick of adoption of the Internet protocols. There was a great deal of tension and argument over what should become the international standard. And in this case, I think practical engineering spoke more loudly than theoretical documentation.
Companies, some of them have fallen by the wayside. We now have a lot of issues with governments. What are the challenges?
I'm sorry, Dave, I missed the first part of the sentence. Would you repeat, please?
I was asking you the challenges today, some of which may be governments. What do you see as the biggest challenges today?
This leading up to 2025 in particular? David, are you there?
Take it wherever you want to take it.
Okay. Well, look, first of all, I would like to have everyone online if they want to be online. I think that we should remove as many barriers as possible to people having not only access to use the Internet, but to provide new products and services on it. And so keeping the network open in that sense, easily accessed, easily accessible for the purposes of building applications, I think is very important. Standards are also equally important because they are a substitute for having lots and lots of bilateral agreements about how things are going to work. Standards allow that to happen implicitly, and that's a powerful tool in our hands. I think what probably is the most important is that by creating these standards and standard interfaces, we open up opportunities for a great deal of competition. This is despite the fact that some people believe that standards can inhibit competition, and I'd like to expand on that in just a moment. But for the most part, I think it creates a kind of a level tabletop on top of which people are able to build competing applications. You see this in the smartphone world where there's a standard programming interface, application programming interface. The application developers don't actually need to know very much about how the mobile system actually works. All they need to know is if you give me this information, I will deliver it to some computer on the Internet somewhere in order to implement the application. and vice versa, you'll be able to receive things coming back. And so as long as you know how that interface works, you don't have to worry about the rest. And the internet is a lot like that too. And if you know how to send and receive internet packets according to the internet protocol, you don't necessarily have to know anything about all the underlying stuff that glues all these various independent networks together. So the standardization and standardized programming interfaces, I think, are very, very vital. Perhaps as important as all of the technology is, it's convincing governments that infrastructure is important and it is worth investing in. Here we get into questions about where capital will come from, what business models will allow the network to grow and allow widespread access to it. And I think that we're aided in that objective by new technologies that are coming along. For example, one of the more interesting satellite-based systems that was launched last year is called O3B, which stands for Other 3 Billion. This is a multi-satellite system that's in equatorial orbit at 8,000 kilometers. It has multiple spot beams, and if I remember right, each one could go up to a gigabit per second each, reaching down to the surface 40 degrees north and south of the equator. Well, that covers a lot of the Pacific Ocean. It covers sub-Saharan Africa, it covers South America and parts of North America and Europe and so on. It's actually quite a powerful system, providing access to places that might have great difficulty terminating fiber. So we have that aspect that's going on, not counting, again, the reference to mobile infrastructure. And then we've got increasing amounts of cable capacity, optical fiber in particular, and new ways of modulating the signals in order to extract more and more bandwidth per optical wavelength. So I would have to say that the trends generally in terms of cost per bit per second and cost per device have been coming down, which is wonderful because that means that a broader and broader population, possibly operating with lower annual or per capita incomes, can access and make use of the network and even provide services on it. So these are all trends that I think are very optimistic and positive. The trends that are not so positive are the ones associated with dealing with abuse of the network. And here we get into some of the things I mentioned earlier, which I won't repeat, but we really do need international agreements and agreements for mechanisms that will allow law enforcement to deal with victims in one country who might have been attacked by people in another country, and at the same time allow you and me to protect ourselves by being thoughtful about safe networking, something that everyone needs to learn how to do.
Marconi Society Webinar. You can catch Vint and other outstanding engineers in Washington on October 2nd. Go to marconisociety.org for details on the symposium. Vint, you were just talking about satellites. Who's behind that satellite display?
Well, the O3B satellite system was actually the first CEO was Greg Weiler, if I remember right, who was an enormous enthusiast for getting internet access to people who would not normally have convenient ways of reaching it, like out in the middle of Pacific Islands, for example, or in the middle of places that didn't normally have access to optical fiber. If you look at Africa, this is an example. There's lots of optical fiber terminating at the edges of the continent, where the Atlantic Ocean and the other oceans meet the edges. But penetrating inside is harder. It's getting better and better over time. But I think his model, which Google also, by the way, agreed with, that we made a big investment in that system, it was that the satellite system would augment whatever underlying capacity might be available from other media. So that's one of a number of different initiatives that are now underway. You're probably aware that Google has an experiment underway called the Project Loon, which is essentially a balloon network up at 60,000 feet. They would provide Wi-Fi capability or LTE capability from this literally low-flying satellite, if you like. There are also some ideas behind the use of drones for similar purposes. if I'm remembering correctly, Amazon made an investment in that direction, and so has Google with Titan Aerospace. So I think you can anticipate quite a wide range of ways in which the internet access might be provided. And this, I think, is good news because it means that there's a lot of different choices with varying economics and varying difficulty of implementation, maintenance, and operation. And therefore, we may have a higher probability of getting everybody online than we have had in the past.
It happens, satellite access so far. But I think the one you're talking about is in lunar orbit, and there's going to be a lot lower latency. Am I remembering that right?
Well, the O3B is low latency because of its 8,000 kilometer orbit instead of the usual 36,000 kilometers, which is about a quarter of a second up and down. 8,000 kilometers gives you about a 50 millisecond round trip time. The balloon case is even lower latency because of its altitude. So in the end, you start to get systems that feel a lot like terrestrial kinds of network delays, as opposed to the classic satellite delays, which we've all come to find very frustrating because of the relative time.
Is they have YouTube, Google Hangouts, and they're all merged into a product that I think we may try next time we do one of the webinars. No rude things about the service we're using. I know the sound is not what I wish it could be, but I think next time we're going to try Vint's companies, Google, to see what comes up with there. Let me take a minute to thank some of the people who signed up for this. We've got an interesting crowd. The former CTO of Apple Publishing, one of the biggest manufacturers in the world. Mike Nelson, who worked with Al Gore. Now, what was Al Gore's real role in the internet? I think you'll surprise people with that answer.
Well, it turns out that Al actually had a good deal to do with the expansion of the internet in the academic and educational space. When he was still a senator, he convened a meeting in late 1986, in the fall, I think, to talk about what he called the information highway. And in the course of that discussion, he posed the question whether the National Science Foundation should build an optical fiber network to link its supercomputer centers to each other and to the rest of the academic community. Well, the head of the NSF Computer and Information Systems and Engineering Group, at that time Gordon Bell, went off in February the following year, '87, convened a big meeting where many of us attended, and came back with a proposal for the National Research and Education Network. And so I think Al gets some credit for having triggered that initiative, in addition, of course, to the people at NSF who took up the charge. Then, as the vice president, Al Gore once again intervened because there was an issue in 1988 about whether any of the government backbone networks could be used for anything other than government business or academic research, military and Department of Energy and NASA and so on. And the question was, what about the private sector? What about the general public? And at that point, late '88, the general public and the private sector did not have access to the network. So by good fortune, I managed to get permission from the Federal Networking Council of the time to hook up MCI Mail, which is a commercial service, to the internet. And not very much longer after that, around 1992, I think, Rick Boucher, who was a congressman at the time from Virginia, introduced a bill that said it was okay for commercial traffic to pass over the government-sponsored backbones in order to allow for this important connectivity everywhere. And Vice President Gore was very active in supporting that bill. So I think that he deserves a great deal of credit on the policy side for helping to facilitate the growth and expansion of the internet in its early days.
So, Vint, You were on, was it Colbert, who was very upset when he heard you complimenting Al Gore?
Good question, actually.
It was either Colbert or Jon Stewart. And he objected because he could no longer
No.
about Al Gore.
Well, wait a minute. Now, you remember that Stephen has a certain character that he portrays in his television show. So let's separate the character that Stephen plays from Stephen Colbert himself, who's actually a closet geek. He loves this stuff. I think he was a little surprised to discover that Al actually did have an important role in all this, and Bob Kahn and I both have written about that in order to try to set the record straight.
Happy Hamlin, especially if I didn't get the question, but was administrating Marconi. And we had 3 people sign up in the ITU. Vint, there's been a lot of struggles around the ITU and internet governance. There's a lot of changes happening. What would make you optimistic?
Well, there are several things. First of all, the ITU is a venerable organization, as some of you will know. It was formed in the mid 1800s after the telegraph system had been not only invented but very rapidly proliferated around the world, and they were formed in order to establish standards for that. And as the telephone spread, it became the International Telecommunication Union, again, to help set standards for that. And they have continued to contribute over time to transmission standards, switching standards, and the like, which underlie much of the Internet's operation. ITUR, by the way, the radio side, has also contributed to not only allocation of frequencies, but also some standards that are today allowing increasingly high-speed implementation of transmissions. So the ITU's had a pretty significant role in providing an underlying infrastructure for the Internet to run on top of. They've also highlighted issues related to security and safety in the network. And although I think many of us are not persuaded that the ITU should be taking an active, overt role in security, I think that the highlighting of the need for attention there, I think, has been useful. They are, as you know, will be having their quadrennial plenipotentiary meeting coming up in October, I believe, in Busan, South Korea, where they will be reviewing once again their 4-year plan for years going forward. So I hope that the countries that participate in that will recognize the appropriate role for the ITU, I think largely focused on transmission standards and things of that kind, and that there are other entities that are part of the Internet ecosystem that should be undertaking other parts of Internet expansion, protection, and evolution. And that, of course, now leads to yet one other observation, which is that there are other aspects of Internet use, including business use. So the World Trade Organization may have something to say about conflicts and disagreements arising in the business sector or international trade sector. And then there is intellectual property protection, and the World Intellectual Property Organization may have an important role to play there. Plus the usual suspects in the Internet space, the Internet Society, the Internet Corporation for Assigned Names and Numbers, the Internet Architecture Board, the Internet Engineering Task Force, the Internet Research Task Force, the regional Internet registries and their aggregate called NRO, the Numbers Resource Organization. All of that has to come together somehow over the course of the next year or two in order to build a framework which will in fact continue to support Internet's growth and utility. So I'm imagining over the course of the next year or two that we will see an increasing attention being paid to a kind of web of commitments being made by these various organizations to each other, recognizing their various responsibilities and roles, and recognizing the way in which they can now work together to create more support for the Internet's growth.
In their meetings, we're going to get a new head of the ITU, almost surely Howland's out. I happen to be writing a story about him now. Have you met him in your travels? He was head of the standards group at ITU. He's going to take over as Secretary General.
This is the likely candidate is Hu Lenzhao, who is the Deputy Secretary now. And I have met with him on occasion. More frequently, I've met with the now sitting Secretary General, Hamadoun Touré. They are very committed to making the ITU useful in this space. I'm not surprised at that. I mean, the relevance is important to them.
Let me take you to some technical problems. You are a PhD in this stuff, after all. At a previous Marconi webinar, Andrea Goldschmidt from Stanford said wireless capacity can grow 50 to 100 times in the next 5 to 10 years. Her Stanford colleague, the Marconi fellow, Paul Raj, and Marconi fellow Henry Samueli generally concurred. Is that realistic?
So I think the answer is yes, and it depends a good deal over what distance we might be talking about these high speeds. But it's fair to say, the classic example, if you go off with a radiometer, a wide spectrum radiometer, and you watch to see what kind of activity there is in radio space, you discover that at any moment in time, very little of that radio space is actually actively being transmitted into. The implication of that is that we could probably do a better job of sharing capacity if we had the right kinds of transmission and receiving protocols and modulation schemes. So the people who are arguing that we are not running out of capacity in radio space, I think are saying this because they believe that we could be much more thoughtful and creative in the way in which we actually emit and receive signals in this spectrum. This doesn't even count the earlier discussion that we had about operating at much higher frequencies where there's much larger bandwidth available. You don't get into the what's called percentage bandwidth problem when you're talking about 5 gigahertz of 5 gigahertz of bandwidth at 60 gigahertz frequency. That's less than 10%. And so these are all directions to head in. The MIMO stuff that Paul Raj has worked on, of course, among others, is equally important because it allows us to both steer beams in the direction of the transmitter we're interested in and direct energy to the receiver that we're interested in, thereby reducing the level of interference elsewhere. I think we have lots and lots of room for improving our ability to use the radio spectrum, but the FCC rules in the United States, and maybe similar rules in the ITUR, and other countries will have to adapt to take advantage of these potential that we can imagine by making use of the spectrum in a more shared fashion.
One of the senior people at the FCC has promised to come to the symposium October 2nd and meet with some of the leading engineers like you mentioned. Another Marconi fellow, Marty Cooper, built the first cell phone. He says, "We've never had a spectrum shortage, and I don't expect one." Is he right?
Well, I think Marty, again, is making several points. So he was one of the earliest implementers that I know about to do MIMO. I remember he showed me an 8 antenna system. It was physically rather big, but partly in part because of the frequency it was operating at. But we were driving around in the San Francisco Bay Area over a decade ago, and he was delivering multi-channel video and audio and internet and everything else using this MIMO-based system, which only reinforces, I think, Paul Raj's contributions to this whole theory. So I think that Marty is telling us that there are, in fact, plenty of ways of using radio spectrum that we are not regularly adopting for a variety of different reasons. I don't, sometimes the cost might be too high, but the cost is coming down for these things. And second, our policy for the way in which spectrum is assigned or allocated doesn't necessarily take into account the kind of flexibility implicit in Marty Cooper's observation.
At another Marconi webinar, Dave Clark of MIT reported congestion is rarely a problem on the continuous networks. The main issues with the edge when the networks connect, not technical problems on the networks themselves. Congestion was rare. He's been inside a lot of these networks in the United States. Does that correspond to what you know?
Yes, in several ways, although I think let's be careful here. First of all, it turns out that when you look at the interior of the Internet, remember this network of networks, it's typically the case that you have aggregated flows that are being summed up from all the various sources at the edges of the various networks. And as Glenn Kleinrock will tell you, an aggregated flow has much more uniform, or at least more easily described statistics than the flows right at the edge of the net, which will go up and down with a great deal of variation. And at one moment you're clicking a mouse, and the next thing you know, 150 megabits is coming at you. So the variations at the edge are much higher than the variations in the middle. So if there's a congestion problem, it's often in the access side of the network where there's a lot of variation in contending traffic. But there is one other thing which has become more visible in the recent past, and that's where different networks interconnect with each other, sometimes with direct peering, sometimes going to public peering locations, which are also called Internet exchange points. And it can happen that the parties who are exchanging traffic have not equally built capacity to deal with the amount of traffic that's flowing back and forth between the two, and in some cases there's an asymmetry. So a good example of this arose not too long ago. Netflix, as you can imagine, is the origin of a great deal of traffic going outbound, so is YouTube. And there's often less traffic coming back than there is going out. And so the places where the servers have to get access to the distribution networks may be a place where there is congestion. And we have to figure out not only the technical problem, which is how to build adequate capacity at those interconnect points, but also business models that are suitable for having all parties agree on making sure that the capacity is adequate to treat the load. By the way, you've also seen another response to this question of high disparity and high bandwidth requirement, and that's the construction of what's called content delivery networks, Akamai being one of the first really big ones. But now you see, not too infrequently, content delivery systems that are co-located with an Internet access network, whether it's a fiber network like Fios or a network like Comcast, which might be hybrid fiber coax. Many of these networks actually place content distribution systems co-located with the head end or the central office in order to reduce the need for transfer of data over long distances. Well, by making a copy available to the content distribution network and then repeating that in the local exchange network, you wind up reducing the end-to-end requirements on the network, which is a good thing. So we're seeing a variety of different technical tools and business negotiations to try to reduce the need for high capacity at interconnect points and thereby making the network function more efficiently for everybody. I think we talked a little earlier about a similar phenomenon. The 4G, 3G and 4G networks, the mobile networks, for example, also encounter potential congestion, especially where high data rates are required. And in some cases, it's possible to offload that traffic to a nearby Wi-Fi network, which is why having multi-radio mobile devices, whether it's a pad or a tablet or a mobile itself, can be very beneficial, because now you can take advantage of different kinds of bandwidths and latency in order to serve different needs. And here's where I think that we're likely to see a great deal of evolutionary change and experimentation and exploration as we try to increase the options available for moving traffic from one place to another.
I could listen to Vint Cerf all day, but we're running out of time. We didn't get a chance to talk about John Chockley's ideas about moving DSL and Wi-Fi towards a gigabit. Pretty impressive stuff. Another Marconi webinar. So as we wrap up, what's going to change in the Internet between now and 2025?
I think probably the most important changes will be the applications that we haven't seen yet. The one thing about the internet which has never failed to impress me is its appetite for supporting new applications. And as speeds have gone up, as latencies have come down, as access has spread further around the world, more and more people are discovering ways to use this very, very general infrastructure that many of us had not thought of. And of course, the next big thing is the Internet of Things, the billions of devices that are part of our environment now, but will be part of a network environment in the future, whether that's heating, ventilation, and air conditioning systems, entertainment systems, security systems, multi-screen kinds of applications where you move an application or use of an application from your mobile to a pad to a laptop or desktop to a large screen video display. I think what we are going to see is this sea of SDA, sea of interconnected devices becoming part of this online environment. That will allow us to make much more efficient use of our resources because we'll have some sense for what these applications are using in terms of electricity or gas or other renewables or non-renewables. And it will also pose an enormous challenge because at the same time that I've even mentioned medical information gathering and the like, at the same time that having this stuff online and available is empowering, it also is potentially scary because you don't want the wrong people getting access to the information or controlling some of the systems that are part of this network Internet of Things. And so I think the spotlight will again be on privacy, confidentiality, and access control to assure that only authorized parties have access to information and control to which they are in fact permitted.
If what Vint is saying is interesting to you, and I suspect it is for anyone in technology, October 2nd, Vint and some of the best engineers in the world are coming to Washington, D.C. for a symposium of the Marconi Society. It's free to Internet Society members, government employees. If you're in Washington, get there. If you're not in Washington, the Internet Society, I understand, is going to be webcasting it. We'll have the details for that at marconisociety.org, and I thank you. I want to thank Jenny Bourne and Hattie Hanlon, who helped put this together. Of course, Vint Cerf, and see you in D.C.
I look forward to that, Dave. Thanks so much. See you on the net.
Absolutely. So long all.